took about, I don't know, hour and a half, 2 hours to put together, and found at the end of all the compiling of the video, the microphone was off. But there you go. How has your week been for you guys? Anyhow, as always, let's thank those people that have supported the channel, the few that always do. I don't know what to say. I think that you're like myself. You realise the importance of what we're trying to do here. And in this video, we're going to highlight something as clear as day. I know we're looking at magnetic data, but we're going to highlight something to do with the climate that has missed the mainstream completely. Now, all these climatologists, the billions of pounds they're spending on the weather modelling systems, why haven't they mentioned this anomaly I'm about to bring to your attention later on in this video? I'm going to ask you the question, why do you think this is? After I provide just a few pieces of simple information, or evidence if you like, to support what it is I feel is the cause of this anomaly. It's a huge anomaly, thousands of miles long, and it is blatant to climatologists, yet for some reason there has been no explanation. So let's get on with the video then. We're looking at the geomagnetic data of samples that are taken from the mid-Atlantic ridge during activity of seafloor spreading. This is where lava pushes up through the seafloor at the ridge. If you look on a oceanic chart, you'll see that there's an Atlantic ridge all the way down in the centre of the Atlantic Ocean, and this is the activity that's going on around that region. And during the lava flow is recorded over a period of time. So we've got from the top of this scale that we're looking at, if I just zoom in so you can see, to the bottom of the scale, it's in millions of years. And we can see, if I just zoom in on the top of that scale, the last magnetic reversal is 0.78 million years ago, which is 780,000 years ago. We'll talk a little bit more about that, but let's just talk about the process and how we get this data, the geomagnetic data, from that. So as the lava's flowing, small magnetic material within the lava sets accordingly to the polarity of the poles at that time, and through monitoring the rate at which the seafloor is spreading around the ridge, we can work out how long it takes to reach a certain distance, and from that we can calculate it. Distance divided by time will give us the speed that it's moving, and it'll also, if we do the equation the other way around, time divided by distance, we get or one of the others. It's late again. Okay, I better get it right now, hadn't I? Okay, so it's time divided by distance gives speed, speed divided by time gives distance, and you can reverse that equation round to make either one of those three the subject, whichever way you rearrange it. But moving on, I think you get the point how we get the magnetic data over the period of time. So the point I want to make about the magnetic data that we're looking at is this strip, if I just zoom out again, is the longest strip in the recorded history of collecting this data. Goes back 5 million years ago. So you can see that around 5 million years ago it was happening more frequently, and the rate at which it was happening in short periods of time was more frequent. Not only that, there was less of these longer bars where, longer periods it'd take for the next magnetic reversal. They're black and white. It's just an indication of where the North Pole was at that time, and then it swapped to the south. So it gives us the polarity in the black and white over a period of time, and it shows us also the intervals at which it stayed at that polarity. So I've cleared up that geomagnetic data for you, and not completely confused you with the working out of distance and time and speed, but I think you get the point. the argument here is, this is not the anomaly that I want to talk about in a few minutes. The argument here is that, you know, this has been the longest period of time at the top, is the most recent, and that is the longest period of time since we've had a magnetic reversal. But you could see there was other periods of time where the polarity was different, that it was in an extended time compared to, you know, over 3 million years ago on the chart, which is around about here. And I just hope the audio is in sync with the cursors moving here. So if it's not, then you'll just have to forgive me, because sometimes when we upload to YouTube, the audio does go slightly out of sync with the video. And that's why I try not to, if I can, you know, use the pointer in the video, because, you know, I've done it before on the, you know, the climate model, when we're talking about weather. I'm talking about something happening over in the east and the pointer's in the north. So just forgive me for that. So as you can see, it does seem to have been slowing down. That's the point I want to make. You know, these periods of long intervals in the reversals have been more frequent towards the time that we are at the present. So you can see this one has taken a really long time compared to the others, 780,000 years. And to me, looking at data like this would suggest that something is slowing down in the core of this planet. And this is one thing that is not being talked about. I mean, as well as the magnetic reversal that we're in, you know, 90% of the people on this planet, or even more of a percentage, don't even know that we're in a geomagnetic reversal. And those that do know that we're in a geomagnetic reversal don't know that this is such a rare event, that it happened the last time 780,000 years ago, nearly 3/4 of a million, well, over 3/4 of a million years ago. So it's a real unique time with regards to the geological anomalies that take place on this planet. And, you know, what I've been trying to tell people is that the magnetic poles, when they reverse, it is a major planetarial change and part of the mechanics that happens in planets. Just to bear, you know, a bit of importance on what I'm talking about, Mars at one point had a magnetosphere that was generated by the dynamo within Mars's core, and it no longer has that. As a result of losing its magnetosphere, it lost its atmosphere, and as a result of losing the atmosphere, it left it, you know, vulnerable to also lose its liquid water on the planet. Now, putting this into context, you're looking at the geomagnetic data that suggests that something is slowing down within our core, and the question is, could we be going down the same road as what Mars has gone? Now, if that is the case, you know, you can see now the importance of this topic and why I've been doing it for so long, can't you? Because it threatens every species across all the range of biodiversity on this planet, every life form, right down to the microbial life form. If we lose our atmosphere, it will certainly, even during a reversal period of when the magnetosphere is down to its very low percentages, cause sputtering effects, which is a stripping away of the atmosphere. If the magnetosphere stays continuously down and doesn't reverse, you know, the poles don't reverse and then regain a full strength magnetosphere, then this planet is doomed as far as life supporting, you know, and what we've been accustomed to over these years that we've been, you know, inhabitants on this planet as an intelligent species. And that doesn't mean, you know, that this is a doom and gloom video. This is facts supporting, you know, one of the possible outcomes we could be genuinely facing in the not too distant future. And when I say the not too distant future, I certainly believe that it's going to be within the next 10 years or even sooner. And the reason why I say this is because if we look at the rate which the magnetic pole has been migrating in shorter distances of time, we can see that it is now covering more ground in less time. And not only that, since 2014, it is no longer heading on that single vector towards Siberia. It's diverted. That's an indication to me that this is now going into the weak field lines, and it is for that reason that we will be going through a magnetic reversal in the not too distant future. This is a Earth planetary size momentum, right? Things happen slowly. We've been in this reversal for the last 100 years, but that isn't an indication to say that we are going to be in it for another 1,000 years, like some of these scientists have suggested. You know, that magnetic reversals happen in thousands of years as opposed to months. Well, that's not the case. You know, people in the Middle East studying lava flows have seen failed reversals. Now, in between these intervals where we've got permanent reversals, there has been intervals, and one was around about 20,000 years ago, 21,000 years ago. We have failed reversals where the pole reverses but doesn't hold the polarity very long before it comes back to, you know, its position again somewhere over the northern hemisphere. But the point is, you know, that even though... So what anomaly am I talking about then? Well, I'm talking about the anomaly of warm temperature that seems to be sustaining in this region. It's covering England and the west of Ireland and the North Atlantic, and reaching right up almost into the Antarctic Circle. Why haven't they mentioned this anomaly at all? Well, it could be for two reasons. One, they simply don't know, or they've not even noticed it. I think it's unlikely. Or two, even talking about this anomaly could lead to the truth of the matter. Now I want to show you something on a different map, if I can get it up, the W3. I'm going to mess about with the scale so we can fit in the geomagnetic data and have a look at that as well at the same time for us, so we can put this into perspective and suggest, you know, what could be causing this warmer temperature to be rising over the Atlantic or the North Atlantic Sea and England, north of England as well. Okay, so some of you may have figured it out yourselves why it is, looking at the temperature on the left and the geomagnetic data gained by the ESA, which was captured by the SWARM mission, those 3 satellites that were sent up to monitor the magnetic fields and the changing fields of the Earth. And we can see the 2 plumed regions over the right hand side on the geomagnetic data. The field strength is very strong, but in the centre it's weak, and over the both north and over the north side, the left and the right of this planet, we've got 2 regions where those on the magnetic data, where those regions are stronger in field, they're colder in temperature, and in the middle, where the magnetic field is weaker on the right chart on the SWARM data, we have it warmer. I know that the scale is slightly not quite as you see going over towards Australia, but it does match, and it hasn't matched as good as this, and I know now for why that is. It's because the time at which SWARM took the data is why it plumed up so much on the one side, because at different times of the year we get this temperature you know, not stand out so much on the southern hemisphere of this planet for some reason. But you can see, you know, we've got a large plume here of strong magnetic field on the magnetic data, and on the temperature chart on the southern hemisphere over the Antarctic, we have a very, very cold region where that magnetic plume is. This fits very nicely with the experiments we've done where, magnetic bearing material, when it starts to get hot, starts to lose its magnetic ability to hold on to stronger fields. And that is the reason why we don't have magnetic poles around the equatorial regions. That's why we have the magnetic poles in these Antarctic regions. It's because it's very cold, and the magnetic ability for the material around these regions is better suited for where the poles will be. And that's why I say when these poles move, wherever their new locations are, is going to be probably favouring colder regions, which is probably why they reverse completely. I don't know whether they do reverse to 180 degrees or something else affects them that moves them geologically to a new location. I do know that one thing, that the North and South Poles have not always been very cold climates on this planet. At some point they have been very warm, and evidence of that is the shale that is found in there. That's why your gas companies are so interested in North Sea gas. It's because of the sediment that has been formed over the millions of years, was of a biological form or carbon based, and that's where your hydrocarbons are being generated from over millions and millions of years, like your gases that you get and your oils and things like that. But you can see the point that I want to make is that there is a very distinct pattern in the centre of these two cold regions, and on the magnetic chart it is where the magnetic field is the weakest. And it is a surprise that your climatologists who, enjoy a great big fat salary every year haven't brought this to the attention of the public. After all, it is public money that they get paid by. And it's the same for a lot of these organisations. I do understand that Swarm had I believe, and this has not been declared, but they had a secondary purpose for putting Swarm satellites up, and that is because the later generation of fighter aircraft use magnetic data for its ability to hug the ground and guide it over the terrain. It's actually using magnetic data, and it can only be really getting it from, the latest source, which would be the European Space Agency and the Swarm mission. You see, we don't get to hear about these things, but it just makes perfect sense, doesn't it? And, if you remember that story, not so long back, about a Russian aircraft off the west coast of the States monitoring magnetic anomalies that were changing at the time, 2 American fighter jets crashed, coincidentally. So, I think, you can link the dots here, and you'll come up with some answers. But why they're not mentioning this really is a shame on them, because it's in your face. This anomaly has been there for years and years, and nobody's mentioned it. Just like the data that we see on the right hand side of the screen, has now been out for years. So for me to come out and mention it to you guys, and nobody else yet to mention it, is pitiful, really, because I'm on a real mega low shoestring budget here. It's crowdfunded, and I still, and in my view, covering more ground than what these guys are, and yet they've got the availability of all the funding they need, all the equipment they need, and yet nothing comes from it, or very little. I know for a fact that you can't get level 2A data out of Swarm, perhaps because it's classified because of what it's being used for. It's probably not that they're interested really in the magnetic reversal and the changes, or that could be the secondary prime goal of their data gathering, but obviously it's for a military purpose. is their, priority here, and that at a time where, such a rare event is taking place on this planet is a crying shame. It's heartbreakingly wrong. It shouldn't be the way it is, because this is way more important than, the ability of a fighter jet, which is a complete waste of money in my view, getting the attention as opposed to the public getting the attention, and perhaps something, being developed that could possibly protect this planet during a reversal. And people might say, well, there's nothing you can do, this is on a planetary scale. I understand that, but I also understand through some of the experiments that I've conducted that you can deflect cosmic rays with ion wind, and you can produce ion wind. So why don't we produce ion wind shields? If not over the whole of this Earth, why not over cities? That's what I'm suggesting. Or if we can't do it over cities, what about over, our own homes? This technology is not that hard to create. What we do need with this technology is a method of storing the energy cheaply enough, because it is something that eats up energy, but it does work. That's the payoff. That's the thing. Anyhow, guys, I wanted to bring you those two things. A little bit of information on the geomagnetic data, how it's gathered, how we know where we are with the pole shifts and the previous pole shifts and the current pole shift, and this anomaly that's not been mentioned once by any climatologist, not from NASA, not from the ESA, European Space Agency, not from NOAA, none of them. You heard it here first, guys, remember that. And with that, guys, I'm going to say, guys, if you want to help support this channel, the link's down there below. It's always usually just a few people. It'd be great if we could get some, funding going. I could probably put more of my time into finishing off the calibrations of the trimagnetometer station and the magnetosphere sensor that's going to monitor the, ongoing weakening of the magnetosphere. And, I probably wouldn't have to stay up till early hours of the morning, to cram a video in once a week for you guys. I could probably do them more frequently. It's just a fact of life. I'm like you guys out there. I have to, put bread on my table. I have to go out. I do two or three jobs now. I do to keep things going as well as this. So, I'm not asking for sympathy by any, no means at all. I'm not asking for sympathy. I'm just saying, my boat is full and it's just barely floating most of the time. So, I do the best I can. The thing is, I think sometimes, you spread yourself way too thin, and you can't put your your best into everything. But I always try, if I can, to at least do one of these videos a week for you guys, and I'll try and find more information out for you. So like I say, I won't keep you any longer. I can only apologise for the giant video that I've had to put up just to get this information out, but I do like to cover as much as I possibly can, so that you get a better idea, as opposed to some people just whack out these short videos, very little detail. And it seems scripted, it seems a little bit artificial, but nevertheless, we all have our styles, don't we? Guys, links there below, and as always, you enjoy your